This is Novel Science. Hi, before beginning this video, I would like to recommend all viewers to revise Newton's laws of motion and the concept of relative acceleration. I've mentioned some links in the description. We all know about Newton's laws of motion, but is there any case where Newton's laws fail? In this video, we will be looking at one such case. Consider yourself standing on ground. Let's say a friend of yours who loves the color pink is in a pink lift falling freely. By falling freely, I mean that the acceleration is 10 meters per second squared downwards. And another friend is in a red lift just beside the pink one. Let's take the acceleration of the person in the red lift to be 5 meters per second squared downwards. Also, I would like to note that I've taken the value of small g to be 10 meters per second squared throughout this video. Now let's look at the forces acting on the person in the pink lift as viewed from the ground frame. One force is the force of gravity equal to mg, and the other is the normal force exerted by the surface of the lift. Therefore, the resultant force is mg minus normal downwards. Also, the resultant acceleration, denoted by a sub r, as we have assumed, is 10 meters per second squared. So, by using Newton's second law, that is, the resultant force equals mass times resultant acceleration, we can write that mg minus normal is equal to 10m. By solving, we get the value of normal to be 0 newtons. Alright, let's do the same thing from the red frame. The relative acceleration of the pink lift from the red frame is equal to the acceleration of pink lift from the ground minus the acceleration of the red frame with respect to the ground, which comes out to be 5 meters per second squared. The resultant force, like before, is mg minus normal downwards. By using Newton's second law, we get that the value of normal is 5m, where m is the mass of the person. Wait, what? The normal force is both 5m and 0 at the same time? How? Well, this is only possible if the mass of the person is 0 kilograms, which we definitely know that it's not. Even newborn babies are fat and have mass, right? Boom! We got a paradox. Let's try to resolve this. First, let's look at the two types of frames, inertial and non-inertial. The inertial frame is an idealistic frame which has 0 acceleration. In reality, no frame is inertial, but we can temporarily define an inertial frame for a particular situation, and in this case, it is the ground frame. The non-inertial frame is said to have some acceleration with respect to the inertial frame, which in this case is the red frame. To avoid such paradoxes, a concept called pseudo force has been defined. It is negative of the mass of the object getting observed times the acceleration of the non-inertial frame. The negative sign basically flips the direction, and don't forget it, even though it may spread a little bit of negativity. And now, the fun part. Let's go! The diagram is the exact same as before, but this time we're going to add a pseudo force, as we are viewing the pink lift from a non-inertial frame. The pseudo force will be mass of the person, which is m, times the acceleration of the non-inertial frame, which is 5 downwards, and the negative of all that, which will change the direction, resulting into 5m upwards. Now write the equation by using Newton's second law, and then solve for the normal. The answer comes out to be, and we deserve a drum roll here, wait for it, 0! I've never been happier with a 0 for my whole life until this moment.